Good morning. Today we shall discuss about VLSI chip design flow. Myself, I am Suresh Babu, working in Hindustan College of Engineering and Technology. And these are the overall topics we are going to discuss today. First of all, what is VLSI? Design flow, requirements, specifications, architecture, digital design, verification, logic synthesis, PNR and validation. First is VLSI. VLSI stands for Very Large Scale Integration. It's the ability to pack large number of transistors and other components in a single chip, and it allows the allows and creation of ICs with a high level performance, efficiency, and reliability, which can be used for many applications. And coming to the design flow, we have different stages. One is stage one. In stage one, we need to collect the requirements, and from the requirements, we have to define the specification. And once the specification is met, we have to go for the architectural specification. And in stage 2 we have to carry out the coding process. First is the design of RTL, and next is the logic synthesis, and third one is the logic equivalence check, and last is the placement and routing. And finally, after routing, we have to move to stage 3. In stage 3 we have to go for post silicon validation. And about the requirements, this is the first step in the design flow. We need to get the requirements from the customer, and we have to answer these questions. For first is what your product will do, how it can be used for, and what's the performance metrics we need to meet. And once these requirements are defined, it can be used to get the inputs, and we start the design of architecture and layout. And after gathering these information, the desired frequency, performance, and power, and other specification requirements, we can able to get it. And the specification, the system specification or the initial phase in VLSI design flow. Here, after completing the specification process, um, in the report, these are all the things we can able to gather. That is, it requires the computational power to run the imaging algorithm. What kind of algorithm we can able to select, and it requires 2 ARM processor with coherent 600 megahertz, and it has to support this much pixel display. These are all the things we can able to derive after completing the specification step. And next is the architecture. After once the specification is completed, we can design the architecture, and this architecture comes up with the system level view, and they will decide what all the components are required, and how much clock frequency is required to run, and how much target power and performance is required. And also they will decide the flow of data inside the chip, as like the normal architecture in a microprocessor or microcontroller. Here also we have a kind of architecture, and it has interconnection of buses along with the components. Many blocks are available, like RAM, ROM, and then PSW, ADC. These different blocks are combined together to form the specific design flow. And next comes the digital design. Here, the hardware description language is used to design the digital design. A Verilog or VHDL code can be used to implement the design. And this is a level of abstraction. It starts from the system level. That is the topmost level of abstraction. Next is the algorithmic level, and third is the architectural level, and next is the register transfer level and gate level, and last is the transistor level of description. And next comes the verification phase. Here in this verification phase, the purpose of the verification is to ensure that the design function correctly or not. Here the system Verilog provides the verification phase, and it provides many constructs and features for the verification purpose, and the different constructs or coverage, discipline, functional coverage, constraint random testing, and assertion. Using these constructs, we can verify the design exactly. And next is the logic synthesis. Logic synthesis is the crucial step in VLSI design process. It involves the translation of high-level language to netlist. Normally, after writing the code, our function is to convert the code into specified netlist. Okay, this logic synthesis step will do the function of conversion of Verilog code to the netlist. And the primary goal of logic synthesis is to optimize the design for various metrics such as power, area, performance, and to meet the specific requirements. And next is the backend, that is the placement and routing. The first process is placement, and here in this placement, the global placement is assigned is to assign the specified location, and in detailed placement we have to do all the things. And next is the routing, and in routing we have two different steps. One is global routing, another one is detailed routing. And in this global routing, it determines the general path for interconnection. It won't connect internally, but in case of detailed routing, we have to do the internal connections, and the metal tracks and wires will be connected in detailed routing. And next is the clock tree synthesis. In this clock tree synthesis, the creation of optimized clock distribution network will be found out. And to ensure the stability of reliable clock signal, the clock elements are placed in the design. And next is the validation. This is the last process. And this validation phase, the process of confirming the fabricated integrated circuits to meet the specified requirements will be set during this phase. And the following are the key aspects in validation. It has to ensure the functional validation and timing validation, power validation, electrical validation, temperature, and manufacturing validation. Means that we have to check whether all these requirements and all these things are met out or not. Thank you.